Okay, so let's begin our unit on matter and change. So the first thing we're going to talk about is the difference between extensive and intensive properties. So extensive properties, they depend on amount of matter in a sample. So these are going to be things like our mass, our volume. That's going to change depending on how much sample we have. So mass is the measurement of amount of sample. Where our volume, that's going to be the measure of the space that sample occupies. So these are some formal definitions. You guys should be pretty familiar with taking the mass or volume of an object. What else could be an extensive property? What else is something that changes depending on how much you have? Yeah? Guys are so sleepy this morning. What about length? That's another good one. Depending on how much you have, you can measure the length of something. Now, our intensive properties, this depends only on the type. Not amount. So I give this example of hardness. No matter if you have a small piece of material or huge, it's going to have that same hardness. What else? What are some ideas of intensive properties? What doesn't change no matter what you have? How much of it you have, I should say. I'll sit here. Yeah. Oh, sorry. Go ahead. Color. That's fantastic. Yes. What else doesn't matter if you have a little or a lot? Trying to wake up your brains a little bit here. What about density? Does that change depending on how much you have? No. So that would be an example of intensive. So I'm going to say color. We said that. Density. Because even though the amount of substance you have may get larger if you're looking at two different pieces of gold, so does the volume. So it's a ratio that increases. So, but the overall value stays the same, no matter on if you have a small piece or a large piece. Now, substance. This is going to be one of our kind of more generalized way to refer to something. So a substance is a matter with uniform and definite composition. So this would be, for example, if I have salt water, I could call that a substance of mine. And so what's important to note is even if I have a big container of salt water, if I take out just a little bit of it, it's going to have the same intensive properties as the rest of the container. So what's important to note about a given substance is that they have or has identical intensive properties. Why do you think it doesn't? Why do they have identical intensive properties? If I have a big container of salt and I take a tablespoon out of it, why does that have the same properties as what's in the container? Because it's still salt. It's the same composition. So again, an intensive property doesn't matter how much you have. It just specifically deals with the composition. Now, if you were to take the mass of that tablespoon and what's left, are those going to be the same? No. So that was, again, what we call extensive properties. So one thing I want to note here is when you see intensive, think of another I word, identity. Intensive has to do with the identity of the substance, not the amount. All right. Any questions so far? All right, so we're going to talk a little bit about physical properties then. So physical property, this is a quality or condition, bless you, of a substance that can be observed So quality or condition of a substance that can be observed or measured this is the key part here, without changing. What do you guys think? What about physical property? What are we not changing when we look at physical properties? What it is that you said? Yeah. So composition. Good stuff. So one of the major things that we discuss are the states of matter. This is something that we can change all the time without changing the composition of stuff. So as you guys should know, there should be review. We've got our solid, liquid, and gas states of matter. Now, thinking about the shape in a solid, is it an indefinite or definite shape of a solid? Does the solid change its shape on its own? Nope. So we're going to say that this solid has a definite shape. What about its volume? Is it constantly changing its volume? Or does it have the same volume of the solid? It stays the same. So definite shape and volume. These things do not change. What about a liquid? I will tell you one of these is indefinite. Is it its shape or volume? What can change? Exactly, right? If you think of a glass of water or my cup of coffee, if I tip it, the shape changes with the cup, right? But it's still the same amount of volume. Now, I wish it would just magically grow, but unfortunately it doesn't. So we have indefinite shape. But definite volume. What about gas? What do you guys predict then for gas? Exactly, both are indefinite. Gases are special because they take the shape and the volume of their container. So indefinite shape and volume. So this figure here, we're just pretending we have a bunch of water molecules. So the first here, this is our solid. So notice how they're in a very specific pattern, same distance, don't have a lot of space to move. They're stuck there. We move to liquid, we start getting a little bit of that movement, but yet again, we won't occupy more space, or sorry, more volume. And then gases, they will take the shape and volume of any container you put them in. All right, so now let's dive into these changes that can occur. Physical change. So we've talked about this a lot. So physical properties are what you can observe without changing the composition. Now, physical change is change of some properties, but not composition. Now we have this idea that physical changes can be classified as two things, reversible or irreversible. What's a reversible change? Yeah, right? What do you, any of you guys still have old fashioned ice cube trays and your fridge doesn't do it for you? You put your liquid in, freeze it, becomes solid, and then you use that solid ice cube, which eventually melts to make your drink holder. So that would be an example of a reversible physical change. What about irreversible? What would happen if I just ripped this in half? Could I magically just wish it back together? No, that would be an irreversible physical change because we'll do an example here. Let's say I rip this piece of paper. I can't magically stick it back together, but does this piece of paper have the same properties? Is it still paper no matter what side it's on? Physical change. So our examples here, we talked about melting, and I'm going to put underneath freezing, right? Because that would be its reverse. This would be an example of reversible. A reversible physical change. I talked about ripping a piece of paper in half is irreversible, but think about you're making breakfast. What if you crack an egg? It's another example, physical change. Still eggshell, but you can't magically put it together. All right, any questions on the definition of physical changes? Okay. We're gonna look at chemical reactions now because I think it's easier to look at physical changes and properties and then directly look at chemical properties and changes so we can see the main differences between the two. So chemical property is a specific chemical change. Oops. Being observed. So now we're going to be switching and talking about the change in composition. And so that's what this next bullet point is for during a chemical change. The composition of matter always changes. Then we have this idea of chemical reactions. We're going to talk lots about those in chemistry class. And so you can have one or more substance changing into one or more. Here's the key word here, new substances. So when we have a chemical reaction, you can either take one thing or multiple things. It undergoes a change into at least one more new substance on the other side. And so you guys, have you heard of reactants and products before? Okay. So reminder that the reactant, this is present at the start of reaction. Our product is produced in reaction. So if we have this idea, we take hydrogen gas and oxygen gas. Let's make some water. What would be our reactants on what side of the arrow? Sorry, this is my arrow. But I have black here. Which side's the reactant side? The left side. So what you start with, what starts at the beginning, so it reads just left to right. These are going to be our reactants. This is our product. Notice how we actually start with two things and make one thing completely different. So yes, this is definitely a chemical reaction. We have new substances that formed. Now, here is what you guys are definitely going to want to get down. These are those clues to chemical change. So when we looked at the banana ripening video, or if boiling water was something. So we have what's called the 4 clues. We have a change in color. If you see that, it indicates a chemical change has occurred. So change in color, production of gas, what do we look for in our reactions to see if gas is forming? What do we look for? Bubbles, yeah. We also have transfer of energy. What do you think I mean by that? Any ideas? What are we looking for a change in, do you think? With exactly, if it gets hot or sometimes it gets cold. So we're looking for a temp change for that guy. And then lastly, we have formation of a precipitate. All that is it's a solid that's produced. So it's solid that forms out of liquid. So sometimes when you mix two liquids together, a solid actually forms. And so that is definitely an indication of a chemical change because it's something new being produced. So this next bullet point is like the one thing I want you to ever take out of any of your science classes, especially this time. During any chemical reaction, the mass of the products is always equal to the mass of the reactants. Does anyone remember what that special law is? Law of what? Starts with a C. Conservation, exactly. So the law of conservation, that's where this comes from. So if you remember anything, you can't just create or destroy matter. It has to go somewhere. This is a really important thing to think about in chemistry, all right? Are there any questions right now? Okay.